Deepak sir, good afternoon.
Good afternoon, ma'am.
Sir, we will wait for another 5 minutes.
Yes, ma'am. No problem. Yeah.
Okay, sir.
So I think so. Can we start, ma'am?
Yes, sir. Yes, sir. We can start.
Yeah. Because there will be other participants.
Yes, sir. Sure, sir. We will start.
Okay, good afternoon, everyone. I welcome you all for the third day of the MDP on multivariate analysis in research. And what really happens when one goes through multivariate analysis or any analytic workshop is the first 2 days will be all theory and will be more tedious enough. And in the last day, you do find that the students, or in terms of the participants who are actually interested in analytics or in research, they will be the one who will be there at the end. So what today is, today what I will be doing is, in the first day we talked about what are the various MVA methods are there in research. In yesterday, what we did was we were able to look at data visualization as well as the unsupervised learning method or the dimension reduction methods which are there. And we just had a look at cluster analysis. Now, if you look at research, the most used tools which are there in the research are regression-based methods. And the most misunderstood methods in research which are there is also regression-based methods. So due to that reason, what I felt is, today, specifically with respect to regression as well as classification-based methods, because either it is in research or either we are talking in terms of analytics, you will be able to understand that this is where maximum amount of research happens, maximum amount of tools which are used, and various variants which are there are also with respect to regression based. And once we understand the regression, then you will be able to notice that when we go for classification based methods, we go for logistic regression, discriminant analysis, everything else, you will be able to notice that there will be slight changes which will be there, but you will be able to understand these methods very, very easily. So for that reason, what I felt is today I'll be discussing on the regression as well as the classification based methods which are most often used in research. So I'll be going through simple, multiple, but what I will be mainly looking at is I'll be going in depth with respect to these two methods, and then I'll jump directly into logistic regression, discriminant analysis, and various other methods which are being used. And then you will be able to understand how the familiarity exists among these methods. So first and foremost, we know that when we go for research, so what we did was, you have collected the data from the questionnaire, everything else, or you have collected the live data, which is unstructured, you have converted that into structured format. Then you notice that you have to understand the variables that you have selected. So you go for various data visualization methods for which you will use ggplot, or you will go for Tableau, you will go for Python. Now, when you have done data visualization, all you are trying to understand is you are trying to understand each and every variable separately. That is, you take one variable at a time, you go through frequencies, descriptive statistics, everything else, or otherwise you try to understand the relationship between two variables, wherein you understand through the scatter plot. Okay, so, or in terms of the facet grid that we looked at, you go for multiple plots, and then you find out, is there any necessity for me to go ahead with any of these dimension reduction methods in the future, or is it possible for me to jump right away into these regression as well as classification based methods? And thus you understand from the data visualization some aspects regarding the variable, and then you move towards the need to reduce the dimensions. Okay, so for which you will be going for factor analysis, principal component analysis, cluster analysis. So when you go for these methods, all you are trying to do is you are trying to reduce the number of variables in such a way that these small number of variables is able to explain maximum percentage of the variation. And once you understand, or once you have reduced the number of variables and you have got some factors which are there or some clusters which are there, you will be able to subject them to various regression based methods or classification based methods. And you know that when we talk about in terms of the time series analysis or predictive analytics, wherein you have got time series data, and you will be able to notice you cannot jump to any classification based methods. You cannot jump into any predictive analytics or time series analytics until and unless you have understood regression, but you have not just understood in terms of theory that y is equal to alpha plus beta x, but you know in depth why regression is very, very important and how it will be able to lead into various other methods, such as we talk about classification, where we make slight changes with respect to dependent variable. If we are going with the predictive analytics, then we talk about a lot of things like serial correlation, heteroscedasticity, and we build in ARIMA models, everything else. So why is that a necessity when we go for the prediction based models? And thus what we'll be discussing today is, when we mainly talk about in terms of first one, when we talk about regression, we all know that all we have is we have certain variables, but we know that dependency exists among these variables. That means there is one variable which is considered as a dependent variable. There are other variables which are there, which are considered to be independent in nature. But what we are trying to do is these independent variables are in turn able to explain certain percentage of the variation in y, but we are not referring here to the causality. So we are not saying that there is a cause and effect relationship between the dependent as well as in terms of the independent variables. So if that is the case, just in terms of a brief, wherein you will be able to notice that since we are going for a dependency technique, and since we are assuming that there is one dependent variable which is metric in nature, and there are various other independent variables, since we are starting from the beginning, we will take one independent variable. We will consider this independent variable to be metric in nature. So we have what is called as a simple linear regression. So you have dependent variable, which is also referred to as a response variable, and the independent variable, which is also referred to as an explanatory variable. And these methods which are there are also referred to as supervised learning methods, is for the reason that when you are testing and when you are validating anything, you will be able to notice that you have the independent variables as well as the dependent variables which are known. Okay, so if that is the case, the regression based methods which are there are very, very helpful in understanding the various other supervised learning methods also. So if that is the case, you will be able to notice that in the literature, in order to say dependent as well as independent variable, you have got various names or nomenclature which exist. But most often what we do is we go with the dependent variable as well as independent variable, or most often which is used is either it is predicand or in terms of the predictors. So in machine learning, we will be able to say these are nothing but the predictor variables which are there, which are independent variables. So if that is the case, all we are trying to do in the regression is, if we know from the validation data set that there exists some relationship, there is possibility for me to come up with the estimating equation. Is this possible for me to predict? Is it possible for me to predict the value of a dependent variable based upon the estimation that I have got or the model that I have arrived at? So if this is the case, you will be able to notice that regression thus helps in validating the hypothesis, wherein all you are trying to do is you are trying to look at some literature and then you are able to say, yeah, does there exist any relationship between independent as well as the dependent variables? And if you are looking at the regression models, you will be able to notice that if one independent variable exists, this is always referred to as a simple linear regression. And there might be a modification to it where we are referring to that it is non-linear in nature. The linearity plays a very, very important role. And when we come across in terms of the regression coefficients for example, alpha as well as beta, you will be able to notice that when we refer to something as a linearity, we are referring to linearity with respect to these regression coefficients, and we are trying to build the same assumption across various other methods also, such as logistic regression. So you have a non-linear which are there are found to be linear in nature. Okay, so if this is the case, what I would first like to go about is, if I am able to consider just I will show the same problems with respect to how it is done in Excel as well as in R, so that it is easier for us to understand the regression much. Yeah. So what we'll be able to do is whenever we take into consideration two variables, in order to know what kind of relationship exists among these variables, whether it is linear or curvilinear, or whether there exists no relationship or not, first and foremost, what we do is we go for plotting the data. And thus, when you look at it, what I have done is I have just taken a few simple problems which are there, which will be able to help us understand the relationship between these two variables. So if I have considered a problem, for example, that there exists some relationship between the entrance test scores which are there and the CGPA scores during the entire semester. So can I consider that there exists a relationship between the entrance test as well as the CGPA? So that can be analyzed first using the plot. So if this is the case, if I go for non-linear regression, I'll just come to that. So if I come to R, okay, so this is as I have taken the data on the entrance test as well as in terms of CGPA, and though it is two basics, I just want to spend 5 minutes here and then I will be going ahead. So you have got the entrance test which is there and the CGPA, and all we are saying is the entrance test is the independent variable and it will have an impact on the CGPA during the entire CGPA for the degree that a student will be able to go through. So there exists some relationship. So all we try to do first is we'll go for the scatter plot. And in the scatter plot, all we are trying to do is we are trying to understand the relationship that exists. So if I go for that, and then if I'm looking at the entrance versus if I'm looking at the CGPA, the X values which are there is nothing but the entrance, and the Y values which are there is nothing but the CGPA. So once we do it, first and foremost, what I need to do is I have to format in terms of the axis. If I have this as, for example, 55. So here is what I'm able to get. So if I just see this, I might be able to say that there exists some linear relationship and it is positive in nature. And if I click on any one of these observations which are there, right click and go to add trend line, you will be able to notice that if I am assuming that there exists linear relationship between the variables, you will be able to notice that the you will be able to get a line. Okay, so how did this line come from? All those things can be discussed, but this is the best fitting line between all the observations which are there. Now, this is a relationship where we will be able to say there exists some positive linear relationship among the variables. Similarly, if I am looking at R, and if I am considering okay, so if I have got, I consider only this. Okay, so here we will just go for read.csv. So I have got a CSV file also, wherein we have got entrance, everything else. This CSV, I'll just go and so entrance test and CGPA. And yesterday also we discussed that if I want to view this data, I will be able to go for view exam, wherein the same data that is there in the Excel sheet is copied right away. So now if I have it, you will be able to look at the head, tail, summary, and in terms of the structure, you will be able to notice that the entrance test and CGPA, these are the two observations or two variables that we have considered. Now, if I want to go ahead with the plot, so what we try to do is, specifically in R, we are looking at two values. One is exam dollar entrance, means I am specifically saying within the data which is there, I have named this data as exam. Within this, I have got a variable, and in order to retrieve the information with respect to the variable, I'll be subsetting that data. This is nothing but in terms of dollar. So exam dollar entrance, exam dollar CGPA. So I'm trying to take these two variables and I am trying to come up with the plot, scatter plot. So if I go for plot function, you will be able to notice that the same thing that we did in Excel, we are able to get. And then what I'm trying to do is, if I am going for the regression analysis, okay, so if I want to find out what is the intercept as well as in terms of the slope, you will be able to notice that what we tend to do is the best shortcut method that we will have is, instead of going for data analysis tool package on the right hand side, here you'll have display R square as well as display equation on the chart and display R square on the chart. So you will now be able to notice that this will be able to give us the estimating equation, wherein y is nothing but the relationship between y and x is given as y is equal to alpha value is minus 1.35 and the beta value which is there is 0.05 and the R square is 0.3. Okay, so this is one method of coming up with the regression coefficients. The second method which is there is, I can come right away to equals to, if I want to find out the intercept with respect to, so if I go for intercept, the known y's here is nothing but the CGPA, comma, the known x is nothing but the entrance exam scores, and you will be able to get the same value which is there. And then we will have to come up with the slope value. So equals to slope, I will have the known y values and I will have the known x values. And I will be able to notice that one way that I got is through the diagram, wherein the intercept value is minus 1.35. This is what we got. And the beta value which is there is 0.05. So we got these values which are there. And using this estimating equation, we will be going further ahead and then figuring out how regression, what was the method which was followed in order to come up with this best fitting line. Okay. Not able to see the comments. Okay, I'll just increase the font size. So here, this is one of the methods which is there. Okay, one is graphical method. One you can directly come up with. The another method which we have is you have got data analysis. Choose the X range. I'll just okay. So this is the entrance test which is there. And then I have got the labels in the first row and the output range, which is I would be considering, because I have opened too many Excel sheets. So here I'll be taking, I want the output range somewhere here, and then I want what is referred to as the residuals. I'll explain all these things. And then if I go for OK, here you will be able to notice that the same results which is there, we have got a lot of output here, but what we tend to first look at is you have got the intercept value which is minus 1.35 and the beta value which is there, we are able to get it as 0.05. So that means in order to understand the relationship that exists between the two variables, we can define that using the intercept, wherein the line will be able to touch the y-axis and the slope, and this slope is able to tell us in terms of what is the change that will happen in the value of y when there is 1% or 1 unit change in the value of x. So what you have got here is in terms of a positive linear relationship. Now, if I go back to R, here I'll just increase the font size. So here, once I run it, you will be able to see the codes here. Okay, so first one, all we have done is we have come up with the plot, and if I want to come up with the regression equation, all we'll be doing is LM here refers to least square method. So LM within the y value and the x value, and then we'll have in terms of the y value. So if I go for a variable called as a regression, use the assignment operator, and then if I go for the least square method and then go for the summary, you will be able to notice that we are able to get in terms of here you have got entrance, you have got in terms of CGPA, and then the coefficients which are there. Here you will be able to notice you are getting here as 27.83 and 16.755. Now, if I go and make changes here, and if I consider this as CGPA, and this is nothing but entrance. Okay, now you will be able to get it correctly, wherein all in R, you will be able to notice that it is y tilde x. So you will be considering the dependent variable first, and then you will be considering the independent variable, and the summary statistics with respect to the output you will be able to get using the summary function. And now if we go for the plot and then the AB line, because I have opened all the rest. Is the this is the relationship that we are able to get between CGPA as well as in terms of entrance. And now if I want to come up with the AB line, which is nothing but the regression line which is there, it is possible for me to plot it. So I've got plot, entrance, regression, summary, plot, as well as in terms of the AB line. Now, if this is the case, you will be able to notice here. Next, what we'll try to do is we'll try to look at the inverse relationship. So what I have tried to do here is I've got the positive relationship between the two variables. I'll just make some slight changes to it, wherein in the format, if I go and select the data, and instead of these values which are there, I will be able to select the X value as well as the Y values. So here you will be able to notice that there exists inverse relationship between two variables. This is linear in nature, but it is inverse. And so for every change in the value of X, Y will be able to decrease. And thus the beta value which is there is negative in nature here. Now, similarly, if I go for selected data, if I go for edit, and now if I'm able to look at the third option, wherein if I consider this diagram which is there, this is not perfectly, I cannot say that it is perfectly linear in nature. So if I want to make any modifications, so if I want to format in terms of the trend line, and if I can say that instead of linear, there might be curvilinear relationships. So these values which are there will be able to explain the variable, but we always talk about overfitting, underfitting in machine learning. So what we are trying to do is we are trying to understand the relationship between two variables, but if the relationship is linear in nature, the simple equation y is equal to alpha plus beta x should be more than enough, or otherwise we should be able to go for higher order. So higher order of x. So you will be able to notice that as I go on increasing, you will be able to see that the model which is there is very, very close to the observations, but is this having the higher predictability power or prediction power or not is the first question that we should be able to ask. So this is nothing but in terms of the positive relationship only, but it is found to be curvilinear in nature. Similarly, if we go for select data, and if I'm looking at so this is what I was showing is you have here the curvilinear relationships, everything else. So if I do take no, just in terms of the linear, if this model which is there is not perfectly explaining the relationship between x as well as in terms of the y variables, I can go with the higher order. So if you go for higher order, though you feel that this equation which is there does a very good job in explaining the relationship between y as well as x, you will be able to understand that does it have the prediction power or not. There will be a lot of problems or in terms of errors when it comes to prediction later on, is what we mostly talk about in terms of overfitting or in terms of the underfitting. So similarly, if I go for R, and if I'm looking at in terms of the same aspect, so if I take a direct curvilinear relationship, we looked at the inverse linear relationship here. Similarly, if I'm going for direct linear relation, curvilinear, I will be taking in terms of the scatter dot smooth. Okay, so if I take scatter dot smooth, you will be able to notice that it is not linear. It understands that the linear relationship will not be, or this linear line which is there might not be able to depict the relationship better. So I should be able to go for a curvilinear relationship. But what if there is more scattering around the regression line? So if I have the linear line, and if I find that the observations which are there are far away from the estimated line, this points towards the relationship that between both the variables not to be, this line to line is not able to depict this relationship, and that association or the degree of association of the relationship can be better understood using the correlation also. And similarly, when we come across certain relationships wherein we are looking at another scenario wherein the observations are somewhere, and then you come up with a line, and this line is not representative at all of the overall observations which are there, or the data which is there, then we will be able to say that no relationship exists among these both variables. So if this is the case, what is really important is when we look at in terms of the second problem also, wherein if I consider the mean temperature as well as in terms of the students who are absent. Okay. Now, if this is the case, we will be going ahead with the same kind of relationship, wherein this same problem I will be taking even for the logistic regression also, as well as in terms of the discriminant analysis also. So what I need to find out here is there any relationship between the students being absent and the temperature which was there during that time? So if I go back to that data, just a minute. And if I'm able to take the okay, so here you have got the student absence data. Okay, so here you have got the student absence data, wherein the absence here is considered as a dependent variable, and the temperature which is there is considered as the independent variable. What's the difference in using Excel or R? Nothing much. The R is much better when we have a larger data set, and that is why we go for R, is for the reason that if I take the same data with 1 lakh observation, then Excel will hang. Okay, so just for that reason, we'll be going for R, which is much more real. When it comes to real-time data, it is possible for us to analyze this data. So due to that reason, we will be able to go for R. So if I have got the Y as well as in terms of X, now what if I want to find out, once again, I'll go to data, then I'll go for data analysis, regression, and here I'll take the Y range is nothing but the absence, and then I have got the X range. Because since there are a lot of files, So here, if I go for regression, it is directly taking the absence and the temperature. So labels, output range, and residuals here. So this is the output that you will be able to get. Okay, and this is the best fitted model that you will be able to look at. Now, what is really important here is when I do come up with the scatter diagram, when I do come up with the relationship and we are able to get the intercept as well as in terms of the slope, everything else. What is very, very important is why did we actually come up with this method? And is there any possibility? Is there any other way, or why this line only? So that is the first question that always comes across. So what we should be able to understand is whenever we go for any classification based methods which are there, we should first be able to understand that how did we arrive at these values which are there, 5.32 as well as in terms of 0.09, and why is it refers to as a least square method. Okay, so why is it referred to as in terms of a least square method, and what are its ramifications which are, and so if that is the case, if I go to insert, if I go to scatter plot once again, and here if I go to select data, in this select data, if I am taking the absence versus if I am considering temperature, the x value is nothing but the absence, and the y value which is there is nothing but in terms of the temperature. Now, if I have these two values which are there, okay, so edit, the x value is temperature and the y value which is there is nothing but the absence. And you will be able to notice that you have certain relationships here, right? And this is not depicted just by in terms of a linear line. You should be able to go for a curvy linear line. So quadratic equation which is there will be much more appropriate when you have to depict this relationship. So I cannot just directly go ahead and then come up with some linear relationship until unless I know in terms of the plot. So if I had come up with a linear line, you will be able to notice that this linear line doesn't depict the relationship between y and x properly. And thus what we should be able to do is we should be able to go for a quadratic function, or we should be able to go for a cubic function, and that best represents the relationship between y as well as in terms of x. Now, what for me, what is important is when we come ahead with these plots, everything else, why this, what is this least square method that everyone talks about, and how is it significant enough for me to understand or in terms of visualize. So if that is the case, all we are trying to do is we are trying to understand this relationship. So if I go for another data set which is called as the least square, and if I open that data set, okay, so here I've got least square. And I'll try to explain using this data itself. Okay, I hope that you are able to see this Excel sheet wherein you have got age as well as in terms of expense. Now, this is a simple case that you can actually look at, wherein all we are trying to do is we are trying to build in some, try to understand the relationship that exists between the age of the car and the expense that will be borne by these cars which are there. And is it possible for me to say if I have got some value of X or age of the car, what will be the predicted expense for that car? So if this is the case, if I look at this data, so first and foremost, what I have told is directly we can go for the chart scatter plot, and then we can understand this is age and versus in terms of expense. X value is nothing but the age, and the Y value which is there is the expense. Okay, so this is what we have got. Okay, and then I should be able to come up with the appropriate line which will be able to depict the relationship between Y as well as in terms of X. Now, the first and foremost thing that we often try to do is if I have come up with in terms of this plot, the entire crux of the least square method is based upon minimizing the sum of square of errors which are there. So if I'm talking about in terms of the error, so if I consider going with the data analysis, or if I know, if I want to find out the intercept value and if I want to find out the slope value, how can I actually come up with this? I can go for intercept. Known value of the Y is nothing but the age, comma, known X value is nothing but the expense. And similarly, if I come with the slope equals to slope, the known value of Y is the expense, comma, the known X value is nothing but the age. So here, known Y value is the expense and X value is nothing but the age. So we have got intercept as well as the slope to be 3.75. Okay. Now, if I go for the same data analysis tool pack and have a look at the regression output, wherein the Y value which is there is expense, X value is the age, and if I take the output range which is there, and I'll take the residuals and I'll say okay, you will be able to notice that you have got these results. And here also it is able to show that the intercept value is nothing but this is 3.75 and the age is nothing but 0.75. But along with that, you will be able to have what is called as the residual output, wherein you have got the predicted value of the expense as well as you have got something called as the residuals. Now, the least square method is based upon this logic that when we talk about least square, what is the least square that they are talking about is in terms of the sum of square of the residual. So if I have got the intercept as well as the slope, if I come up with something called as a Y hat, this is nothing but this is the estimated values. This is the estimated values of the expense of the cars depending upon what the value of X will be. So if I go for wrap text, okay, these are the estimated values. So how will I calculate the estimated value? Since I know that the regression equation which is there, the least square method is nothing but Y is equal to alpha plus beta X. If I go for equals to you have got alpha value which is there is 3.75 plus the beta value which is there is 0.75 into the value of the X, that is nothing but the age. So if I'm using this estimation model and then if I'm saying if the age of a car is 5, according to this estimation model, what will be the expense? So you will be able to notice there exists some difference between what is actual and what is estimated by this model. And since I want to keep this constant, I'll go for function f4. And similarly, the beta value also, I'll go for function f4. And then if I go for it, these y hat value are always referred to as the predicted values. Okay, so if you come across this residual output here, and if you see this plot, and if it is showing as predicted expense, what they are trying to do is they are trying to say, if I have got the estimated equation, if I use that and plug in the values of x, what will be the predicted value of the y? Okay, so these are the predicted expense values. Now, since there exists some differences which are there between the expense, which is y, as well as what is expected, this is always referred to as a error component. So all we are talking about is we are talking about error, and this error is also referred to as residuals. So if I'm talking about these are residuals, what we'll do is we'll have this as y minus y hat. This is the nomenclature which is followed. Now, if I go for actual values, which is there minus what is expected, you will be able to notice that this is what we have got. Okay, this is nothing but residuals. Now, if I say least square method, if I'm going for what is the error part that I'm referring to here is, if I say the error, the residual has to be, if I take the sum of this summation, okay, am I referring to this as the most appropriate way of judging which line will be appropriate in order to explain the relationship? I cannot come up with the residual, or I cannot just come up with the errors, because you will be able to notice that the positive and negative values will be able to negate. I will get it as 0. So this might not be the best method. The error might not be the best method. What if I can come up with the absolute errors? So what if I can come up with y minus y hat? And if I come up with the absolute value of these errors, and if I look at the summation of these errors, the problem with respect to the absolute value is they do not stress on the magnitude of error that exists between various models which are there. So if that is the case, I cannot come up with the mean absolute errors, because when you go for various methods, you will be able to notice in order to judge which model to consider, you will be able to go for mean absolute error. And similarly, what if I can say that if the error part is more, let me penalize those errors, and thus if I go for y minus y hat whole square, what I'm trying to do is I'm trying to look at the errors and I'm trying to penalize these errors. So if I take 0.5 square, okay, and then if I look at the sum of these, okay, so sum of the square of errors, this is referred to as the mean squared error. Okay, if you come across this term called as MSE, what we are mainly referring to is, at the end of the day, whichever model is able to give me this value to be the least, the sum of squared to be the least, I will be able to consider that that line which is there fits the model perfectly. So if that is the case, can I actually come up with this model? So if I have got, this is y hat. So what I'll do is I'll go to design, I'll go to select data. I'll add another one wherein I'll consider the estimated line, where I have got the x value is nothing but the age. I've got the y value which is there is nothing but the y hat. And then if I go for, okay, and here if I change in terms of the plot, change chart type, And in the chart type, if I have this as a line, okay. Okay, so if I have this as a line, you will be able to notice that this is the line which is able to ensure that the distance that exists between the observed values with respect to the points on the estimated line is as minimal as possible. Now this, you can understand that this is a minimization function, okay, wherein we are talking about minimizing the errors. And by going for minimization, what we are trying to minimize, we want to make changes to the intercept and slope, which in turn will be able to reduce this mean squared error as much as possible. So if that is the case, how do we understand this much better is, what if I take intercept to be 1 and slope to be 0? Okay, and if I go to data, you will be able to notice we have got something called as a solver. Okay, so if I go to the solver, what I need to do here is I should be able to come up with a minimization function. And if I come with a minimization function is what minimize the error component which is there, or the mean squared error, I want to reduce it. And I want to reduce it in such a way that this is the minimum value which is there. So I want to come up with the minimum value for this cell. By changing what cells, I want to change the intercept as well as in terms of the slope values. Now, if I go for solve, and if I say keep solver solution, and if I say okay, and now if I look at in terms of the data, you will be able to notice that this solver has what it has tried to do is it has tried to ensure that it reduces the mean squared error, and as it keeps on changing this intercept as well as the slope, it looks at all these numbers or all these values which are there, and whichever value is the minimum, it will be able to consider that. Now, how to actually visually look at it? You will be able to notice if I consider this as 1 and slope as 0, you will be able to notice that all I will try to do is I'll try to make some changes here. So if I say this as 2, intercept as 2, and then if I want to make the changes to the slope, so 0.2. Okay, so 0.22. This is 0.22. Then I'll make change as 0.23. Then I'll make some changes here as 3. So you will be able to notice all I'm trying to do is I'm trying to adjust not only in terms of the intercept, I'm trying to make some changes to the slope also. So here, if I make some changes as 0.25, so I'm trying to make some changes to the intercept as well as slope. And as I'm making these changes, you will be able to notice that the minimum squared error which is there will also keep on minimizing, because all we are trying to look at is we are trying to look at the distance that exists between the observed values with respect to that of estimated values. Now, since I know that the value which is there is 3.75 as well as 0.75, what I'm trying to do is I'm trying to come up with all these combinations. And thus, if you come across when you are learning regression based methods, and when you are learning gradient descent method, so when one talks about gradient descent method, what gradient descent method means is when I go on making some changes to the intercept and slope iteratively, the mean squared error which is there will also start minimizing. So if I take in terms of a screenshot, okay, so here if I consider the screenshot, all we are trying to do is if I go on making some changes to the intercept as well as in terms of the slope, you will be able to notice that the mean squared error which is there will keep on reducing, and it will reduce at a point wherein you cannot make any changes further, and this is the minimum value that you can reach. And this is always referred to as the gradient descent method also, where we are trying to find out the minimum value, and by coming up with the minimum value, which will ensure that the distance of the observed values from the estimated line is as minimal as possible. So coming iteratively making changes to this intercept and slope will in turn result in minimization of the mean squared error, which graphically we will be able to notice that this is the best fitting line that we can come up with. And this, if we come up with this as a best fitting line, this can be further used for forecasting purposes. So if that is the case, if I do come up with further, and if I have come up with the 3.75, this is 3.75, and this is, for example, how much was it? It was 0.75. So if I come up with the 0.75, this is the best line. And once I come up with in terms of the best line, I can use this equation which is there for prediction purposes. So if I want to say, if the age of the car is going to be 4 years, what is the corresponding expense that I can predict? So if I say the equation is y is equal to alpha plus beta into x, I can expect that this might be 6.75. So what we tend to do is, first and foremost, we try to come up with the intercept as well as slope, and then it is possible for us to make some prediction. Now, we do not stop here. We do not want in terms of a point estimate. Okay, so we do not want in terms of a point estimate. What we always say is there any possibility for us to have some confidence intervals? Okay, so if I have some confidence interval, can you tell us 68% of the time the expense which is there will fall between what values? Similarly, 95.5, then in terms of 99.7. So here what we are trying to assume is, we are trying to assume that we are trying to understand the reliability of the equation. So when we talk about reliability, we always come across what is referred to as the standard error. So when I come up with the standard error, you will be able to notice that the standard error that we have got is 0.866. How do we actually calculate is the square root of y minus y hat whole square divided by n minus 2. So if I have this value which is there 1.5, this divided by the n is nothing but 4, so 4 minus 2, and if I take the square root of it, I will be able to get this 0.866. So I have got the standard error. Now, standard error is similar to that of the standard deviation that we use in normal distribution. So wherein standard deviation talks about dispersion of the observations around the mean. Similarly, when we talk about standard error, we are talking about the dispersion of the observations which are there around this estimated line which is there. And if it is 0, that's much better. That means all these observations fall perfectly on this estimated line. And if it goes away from 0, that means we do lose in terms of some predictive power. So if that is the case, if I want to say with confident certain intervals what the expense will be within what intervals, so we will be able to go with, for example, 6.75 is the value that we got. 6.75, if I want to tell about in terms of the lower limit as well as the upper limit, I can take it as 6.75 minus 1 into the standard error that we have. So you have got 5.88, and similarly, if I take 6.75 plus 1 into the standard error, you have got 7.66. So it is possible for you to now say the expense might 68% probability exist that the expense might fall between 5.88 to 7.61. So what we tend to do is we tend to use in terms of the confidence intervals in order to explain it. Now, if this is the case, the what is now, if I'm going back to these slides. So what we looked at is, one is in terms of the standard error and how to come up with in terms of the prediction. When we do the same thing in R, you will be able to notice that R will be able to use the different formula. Okay, so it takes into considerations the standard error into, it will be able to take 1 plus 1 divided by n plus x naught is the value of x minus the mean square summation x square minus n mean square. So you will be able to notice that there is slight change with respect to XL as well as R, is for the reason that this is the formula that will be used there. Now, if I want to say, once I have got the output, the independent variable which is there, is it significant enough or not? Whether this plays a very important role in explaining why. So if my null hypothesis which is there is that the beta value is 0, beta value if it is 0, that means the x doesn't have any predictive power, or x doesn't have, is not capable of explaining. But when I come up with the beta not equal to 0, that means any unit change in the x will definitely have some impact on the value of y. If I have to prove it, what we'll be able to do is, in the literature review, first and foremost, we'll be able to come up with the standard error of the slope. And then once we have come up with, we will be able to calculate the t statistic as well as look at the critical value. And then we'll be able to decide whether to accept or reject. But another way which is given right away is, when you look at this regression output, you will be able to notice that the standard error as well as the t-stat value is already given to you. Okay. So either you can accept or reject the null hypothesis by using this, or you can directly go with the p value. And then since if the alpha level which is there is 0.05, since this value is greater than 0.05, you will be able to accept the null hypothesis that age might not be the only factor, or age might not be playing an important role in explaining the value of y, at least in this case, and there might be several other variables which might be helpful. Okay, so this is one of the aspects. And similarly, in order to know the degree of association relationship between both the variables, what we'll tend to look at is, we'll tend to look at, one is coefficient of determination and another is in terms of the coefficient of correlation. So here, if I do consider in terms of the value, you will be able to notice that 75% of the variation in y is explained by x. And one thing is, when we have a simple linear regression, there is no use for you to come up with the ANOVA right now, is for the reason that you will be able to notice that the p value here as well as for the ANOVA is the same. That means all we will be trying to concentrate upon is whether this independent variable which is there is significant enough or not. Okay, but in terms of the goodness of it, we will not be able to look at it right away. So if this is the case, what I wanted to discuss with respect to regression method is, if you go look at in terms of the least square method, all we are trying to do is we are trying to go for minimization function. So if this is the case, let me close these. Okay, just a minute. But when we come to in terms of the logistic regression, okay. So now, once we have understood something regarding in terms of the regression and what is the major focus that will be given, you will be now be able to notice that what will be the key differences that exist when you go from a dependent variable which is metric in nature and directly jump into another method where the dependent variable which is there is found to be discrete in nature. Okay, so if that is the case, if the dependent variable is discrete, we will be able to go for classification based methods, and within classification based method, the logistic regression which is there is one of the best methods. So when we look at classification based methods, all we are saying is the response variable which is there is discrete in nature, and there are various methods of classification, but I'll try to concentrate mainly in terms of logistic as well as discriminant analysis. And I just want you to understand that relationship that exists between what we have learned in regression with respect to that of logistic regression. So if you will be able to find that logistic regression has found its applications across the banks as well as in specifically in HR and a lot of recommendation systems also. So here, the question that needs to be asked is, how is this going to be different from that of the regression? So if that is the case, you will be able to notice that if the dependent variable which is there, it is having just two levels, we'll be going with the binomial logistic regression, or otherwise if it has more, we'll be able to go for multinomial logistic regression. And if this is the case, there are key steps that has to be followed. Is here what we are trying to ask is, since the dependent variable has got two discrete values like success or failure, what we are trying to ask is, what is the probability that an observation belongs to this class? Okay, so what we are trying to do is, we are trying to ask this question, probability. And since we are talking about probability, the values which are there should be able to fall between 0 as well as in terms of 1. And then we should be able to come up with a cutoff point. So that means if the values are between 0 and 1, if I come up with the cutoff point as 0.5, any value which is greater than 0.5 should be designated as 1. Anything which is less than 0.5 should be designated as another value. So what we tend to do is, in logistic regression, first we come up with the probabilities, or in terms of the values probabilities, and then we will be able to decide upon the cutoff point, and beyond that cutoff point we will be able to classify whether the observation belongs to success or in terms of the failure. So you have got two basic steps which are there. Now if this is the case, you will be able to notice that when I talked about linearity in regression, y is equal to alpha plus beta x, the alpha as well as the beta values were assumed to be linear in nature. So I'm not considering something like 1 divided by beta or e to the power of beta. I'm not considering in this way. I'm considering that the alpha as well as beta regression coefficients which are there are found to be linear in nature. So if that is the case, if I go with the same logic here also, can I get the values between 0 and 1? Because the dependent variable which is there is found to be discrete in nature. And thus, in order to make sure that these values fall between 0 and 1, there are slight mathematical modifications that we will be able to apply. And thus, this is always referred to as in terms of a logic model. So what we'll try to do is, you will be able to notice the steps which are there is, first and foremost is, I should be able to get the probability, and these probability values which are there should be able to fall between 0 and 1. If that is the case, if I take a simple problem, I'll take logistic. age of the car. Okay. So here, notice that this is the problem which is there. If I take the y value which is there as continuous in nature or metric in nature, if I if I take y as well as x, I'll be doing a simple linear regression method. Now, if I do convert the same thing, okay, so if I consider that more than 5 students, if they have not come to the class, I will designate that as absence, okay, or otherwise I will consider not, okay. So if I have just come up with 1 as well as 0, you will be able to notice that this is a dependent variable which is found to be discrete in nature. Now, what is the method that we followed when we discussed in terms of the regression-based method is we will concentrate mainly on minimizing the sum of squared errors. And if this is minimized, automatically we will be able to get the intercept as well as the slope appropriately, and that will be used further for prediction purposes. Now, if this is the case, if I take the same thing here. Okay, so first one is the intercept as well as the slope value. Here, if I come up with the intercept, the known y which is there is student absence, and the known x is nothing but the temperature. And similarly, I will be able to come up with the slope. The slope known y is student absence, and the x value is nothing but the temperature. So I have got intercept as well as in terms of slope. Now, if I say that if the temperature tomorrow is 35, so if I say if the temperature tomorrow is 35, how many number of students will be absent on that day? So I need to predict it. So if I want to predict absence, I will come up with the same formula, y is equal to alpha plus beta value is 0.12 into value of x, which is nothing but 35. And approximately, I can say that 6 students will not be able to come on that day. Now, if I use this same logic, if I apply the same logic here for a discrete data, okay, so if I say instead of the absence here to be continuous, I'll be able to take discrete value, enter, and then I'll go for this to be discrete. Now you will be able to notice what is really important is when I go for these values, okay, if I change these numbers also, for example, equals to random between, if I say 23 to 45, if the number of students who are there absent on any specific day is this, and here you will be able to notice that we have got 1 as well as in terms of zeros which are there. If I use this model, okay, this model will not be appropriate is for the reason that when I go for taking this as a dependent value or the discrete value which is there, and then if I want to use the same regression model which is there, it might not be appropriate in nature is for the reason that I have got the values wherein the value can be either 0 or either they can be 1, and I should be able to classify them as being absent or in terms of present. Okay, so if this is the case, this methodology will never ever work out. I should be able to come up with another logic. So what are the various steps that I can come up with this? You will be able to notice. The first step which is there is I should ensure that there exists some linearity. Okay, so this is the method that we had come up with in terms of linear regression, wherein the independent variables which are there are, and you look at in terms of the partial regression coefficients which are there, beta 2, beta 3, everything else, they are found to be linear in nature. And I want this linearity to be maintained on the right hand side. Okay. But the problem which is there is, if I want to maintain maintain this linearity on the right hand side, the values that I will be able to get here might not be within the interval of 0 as well as 1. So the probability values which will be there might not be between 0 and 1. So I should be able to make some modifications, or I should be able to make some corrections to it. So what are the corrections that I can do is, I should be able to ensure that if I go for the probability function, wherein if I take the non-linear function, because since I know that these values which are there, or the predicted values which are there, are not going to be between 0 and 1. If I want to make it as 0 and 1, I should be able to take exponential of, if this is considered as z. Okay, so if beta 1, beta 2, everything else, this right hand side of the equation, if I consider it as z, if I take the non-linear function of the predictors in this form, e to the power of z divided by 1 plus e to the power of z, you will be able to notice that this is always referred to as a logistic response function. So what we are trying to do here is, if I show the same thing in Excel. Okay, so here I've got the value, predicted value of y is nothing but 0.69, which is there. Now, if I can come up with equals to exponential of this 0.69 and 1 plus equals to 1 plus exponential of this 0.69, if I come up with this, and then if I divide e to the power of z divided by 1 plus e to the power of z, you will be able to notice no matter what I will be able to get here. Okay, so no matter what I get here, because what I'm trying to do is, I'm trying to have these values which are there. This is the intercept. If I take this for the students, as well as if I take it for student absence, if I consider this as a regression based method, you will be able to notice the predicted absence always comes as a value which is greater than 1. It is not between 0 and 1. I should be able to ensure that this which is there, this value which is there, comes somewhere between 0 as well as 1. So I need to be able to make some modifications. So I should be able to go for logistic function which is there. In the logistic function, if I go for e power z divided by 1 plus e power z, you will be able to notice that as I make any changes here between, for example, 2 to 10, if I make any changes here, you will be able to notice no matter what the value of y that I will be able to get, your value which is there, okay, since I made some modifications here, I will be able to get probability of y, and the probability of y will be able to fall below between 0 as well as in terms of 1. So the first modification that we'll be able to do is, we will ensure that this right hand side of the equation is correct. We want the linearity, but the problem with respect to this is, we will not be able to get the value on the left hand side to be between 0 and 1. So we make some changes to it, mathematical changes to it, and this is always referred to as a logistic response function, which ensures that the value will be able to fall between 0 as well as 1. And why we did it in this way, e power z divided by 1 plus e power z, is you will be able to notice that when I go for this function which is there, e power z divided by 1 plus e power z, now the question that I am asking is, what is the probability of not a event not occurring? So if I'm taking the odd function of it, and what I need to ensure here is, the right hand side of the equation is linear in nature. But here you will be able to notice that if I want to get the probability between 0 and 1, right hand side which is there is not linear. That means beta 1, beta 2 values which are there, these are found not to be linear in nature. So if I have to make this linear in nature, I should be able to make some modification. So what I'll do is, if I'm able to take this probability divided by 1 minus probability, so I'll make some mathematical changes here. So probability divided by 1 minus probability, you will be able to notice, since probability y equals to 1 is e power z divided by 1 plus e power z, the probability of an event not occurring, okay, so this is nothing but 1 minus e power z or 1 minus p. So if I take this, at the end result of doing this mathematical change is, on the right hand side I will be able to get it as e power z. So that means this odds function is nothing but e power z. And if I want to make the right hand side linear in nature, I will be able to take the log function of it, and thus you will be able to notice the log of what, why is it referred to as a logistic function, why is it why that name has come in, is due to the reason that in order to ensure that the right hand side of the equation is found to be linear in nature, we are making some changes on the left hand side. And when you take the log of odd function which is there, we will be able to come up with what is called as a logistic function. And thus you will be able to notice that here the major aspect that we'll be concentrating on, when you looked at the regression, we were mainly concentrating on minimizing the residuals which are there. The same thing if you are going for in terms of the logistic regression, you have got for example, you have got the absence as well as in terms of the temperature here. And all I want to do is I should be able to calculate the value of intercept as well as in terms of the beta coefficients, which is on the right hand side of the equation. So I should be able to come up with the intercept as well as the beta. But since the since the dependent variable is found to be discrete in nature, the assumptions that we make for regressions, and this becomes very, very important, the assumptions that we make for regression might not hold good for logistic regression. Okay, so due to that reason, what we'll be able to do is we will be able to go for maximum likelihood function. So if I go with the same method, what are the various steps which are there in order to find out the values for the beta as well as in terms of alpha when we go for logistic function is, first and foremost, we'll find out the logistic function. So here we know that what is the logistic function which is there is, we have here e power z divided by 1 plus e power z, and this will be able to give us the value in terms of the probability between 0 as well as in terms of 1. So if I have a absence as well as in terms of temperature, and what is the value of z, this is similar to what we had in regression, y is equal to alpha plus beta x. So if I do take this same value, if I assume some value here, okay, 0.1 as well as 0.1, and then you will be able to notice that right hand side of the equation which is there, this is in the linear form. So I will consider this as z. And since these values that I have obtained is not between 0 and 1, I should be able to convert these values into 0 and 1. In order to find out those values, I will be making some changes. So I will be taking this probability of y equals to 1 is nothing but e power z divided by 1 plus e power z. And this we know that it is referred to as a logistic function. So if I go for exponential of this z value, so e power, so if I go for exponential, and then if I go for exponential divided by 1 plus exponential, okay, you will be now able to notice that previously all the values that we had got, we are not between 0 and 1, so they cannot be used directly, but we are trying to convert them into probability between 0 as well as 1. Now, since in regression equation, simple linear regression, our concentration was on minimizing, okay? But here, what we are trying to do is, since it is going to be a logistic function, we will be able to go for maximizing the log likelihood function. So when we have to go for likelihood function is given by y, you have got the value of y, which is there. Now y into log of y plus, once again, you have a log of the probability plus 1 minus y into log of 1 minus probability. So if I have got these values, what I am concentrating here is I'm concentrating mainly on this value. Okay, I want to ensure that this value is maximized. Okay, so maximizing the log likelihood function is the main theme, and I should be able to maximize this log likelihood function so that I will be able to get the value of beta as well as in terms of the intercept. So if I once again go to data, okay, so I'll go here. Just a minute. So here, if I go to data and then if I go to solver, now in this solver, what I'm trying to look at is I'm trying to maximize the log likelihood function. So if I go for which is the value that I'm looking at maximizing this value, which is there. Maximizing by changing what all values, I want to change the value of this intercept as well as in terms of slope. So if I go for maximizing it, you will be able to notice if I go for solve and then say, okay, the intercept value will be 0.63 and the beta value which is there is found to be 0.005. And this beta as well as the beta 1 values are able to best classify a dependent variable which is found to be discrete in nature. So what we are trying to do is we are trying to go for maximization of the likelihood function in order to find out the best possible intercept value as well as the beta coefficient value. And by why we are going for it is for the reason that the dependent variable is found to be discrete in nature, and thus if I am able to implement the same thing in a dashboard, okay, if I'm able to implement the same thing in a dashboard, you will be able to notice I have got beta naught, I have got beta 1. Now, depending upon what will be the temperature outside, what is the probability? Okay, so what is the probability that there will be a success or in terms of a failure? So if I go on changing here the temperature, you will be able to notice I will be able to get in terms of the probability value. Okay, so here what I have is I have either in terms of the success or in terms of the failure, and since I have got a cutoff point, I will be able to say that if the value is found to be 0.5, if the cutoff value is found to be 0.5, then I will be able to consider this as yes or otherwise no. So when we go for logistic regression model, we cannot use the same methodology, though there are various other assumptions which are there. You should be able to remember that since the values which are there has to be easily understood, and since the values has to fall between the discrete value of 0 as well as 1, you are trying to make some modifications, and here we are mainly looking at maximizing in terms of the log likelihood function. So similarly, if we are the same classification method which is there, if I am looking at from a point of view of discriminant analysis also. So if I look at discriminant analysis, so if I go to discriminant analysis, you will be able to notice one of the other classification based method is also discriminant analysis, wherein in the discriminant analysis also what we are trying to look at is whether a person will be a buyer or he will not be a buyer. So if I'm looking at this case where I have got certain independent variables, and all I'm trying to do is I'm trying to say whether I can classify the dependent variable appropriately into either one or in terms of a zero. So the discriminant analysis is also used in the research, and depending upon how many discrete values will be there in the dependent variable. If it is just two values, success or failure, buyer or non-buyer, you will have two group discriminant analysis, or we will be able to follow in terms of multiple discriminant analysis. So here what we also try to look at is the same equation. When I started the session in the first class, when I say multivariate analysis, always remember that it is variate. It is nothing but linear combination of the variables. So you might have several variables. You are trying to combine all those variables in such a way that it is able to give you a single value which will be helpful in decision making. So similarly, in terms of discriminant analysis also, you will be able to notice this is same as that of regression, what we saw in simple linear regression or multiple regression. This is same as we have seen with respect to logistic regression also, wherein we want to ensure that there exists linearity on the right hand side. But the problem which is there is in the value of y, whether the value of the y, if it is found to be continuous, go right away with the regression. But if it is found to be discrete in nature, then you will decide what methodology that you will be able to follow. So you have to make some changes to it. And thus, when we are mainly looking at in terms of discriminant analysis, since due to shortage of time, I'll just show it, that you will be able to go for classify, and then you have got discriminant analysis, wherein the grouping variable which is there, we'll consider the dependent variable as the grouping variable, the minimum as well as, so one will be 0, another will be in terms of 1, and then these are all the independent variables which are there. Now, once we have selected the independent variable, similar to how you do in regression, you have got forward regression, backward regression, you have got stepwise regression, everything else. You can follow the same thing here also. And then once we have looked at the correlations, and specifically, I'm looking at the summary table as well as leave on out classification, because when we go for the classification based method, we will be able to come ahead with what is called as the confusion matrix. So in looking at the confusion matrix, what we would be able to judge is this model able to predict much better the dependent variable or not. So when we go for discriminant analysis, first and foremost, you will be able to get this group statistics. In the group statistics, what we mainly look at is, when we look at the buyer as well as in terms of the non-buyer, is there too much of variation between mean as well as in terms of the standard deviation? That means this variable which is there might play a very important role in classifying these two groups or maximizing the variance which is there among these groups so that they can be classified properly. But similarly, when it's in logistic regression also, we have got what is called as Wilks lambda. We have got since there is no correlation values that we can find out, we go for pseudo R squares. Similarly, Nagelkar case, you have got Cox and Snell's, you have got various other methods which are there. Here also what we are trying to do is, if I want to find out, like I did in regression, whether a independent variable is significant or not in classifying the groups, I will be able to look at the Wilks lambda and in terms of the significance level. And then I will be able to decide whether these variables, independent variables that I have considered, are able to explain the dependent variable or not. And when we go for the Wilks lambda also, here you will be able to notice this is nothing but we conducting ANOVA 4 times. So it is able to understand the within as well as between sum of squares, and it is able to find out whether these variables are able to contribute in explaining the variation or not. And that is what I just wanted to explain here also, wherein you have got all these results, everything else. But what is important that I wanted to show is, this is what is referred to as the classification model. Now, in the classification, whenever we go for research, or when we go for machine learning, or when we are looking at business analytics, what we are mainly talking about is the model that we have used. Is it able to classify the true positive as well as the true negative correctly or not? So if I have got totally 18 observations here, if I have used logistic regression, or if I've used discriminant analysis, if I have no non-buyer as well as non-buyer, these are refers to as true negatives. If I find that there is an observation which is a buyer and it has been identified correctly as a buyer also, these are nothing but true positives. So true negative plus true positive, I am looking at the total accuracy of the model. If the total accuracy, if the model is able to do very well, it is able to classify the buyer as buyer and non-buyer as non-buyer, that means it is doing a very good job. But the problem is there are a lot of false positives as well as false negatives, which we should be able to consider. And thus, the percentage of the total true positives or true negatives, we try to understand using sensitivity, specificity. There is something called as ROC curve, or receiver operating characteristics. We consider all those, and then depending upon that, at the end of the day, when I'm using various classification based methods, my entire goal is towards looking at this classification table, or it is also referred to as confusion matrix, and then deciding, is it able to classify the observations correctly or not? Okay. If not, I will be able to make some iterative changes to it, or I will be able to use various different models. And thus, instead of me using just one model, is it possible for me to use several models? So we have got bagging, we have got boosting, we have got random forest methods. So why we are going for all these methods is to ensure that if I can take several models together and then find the best model among these, that will be the best way in which I can find out the model which is able to predict, and the total accuracy of the model can also increase. So this is what I just wanted to explain also, that when we look at multivariate analytic techniques which are there, depending upon what kind of in the literature, what does it say, whether there is a dependency or there is a interdependency. First and foremost, always go with the visualization method. Then if there is a requirement for you to go for unsupervised learning method or dimension reduction method, go for factor analysis, cluster analysis, everything else. So interdependence technique. But when it comes to these models, regression as well as in terms of the various classification based methods which are there, you should be able to first understand what the assumptions are. Is the literature exactly telling you that these the variables that you have considered have some relationship or not? And building upon that, you can go ahead in terms of prediction and all those aspects. So this is completely a cross-sectional data that we will be able to analyze. If it is a time series data, you will be able to notice that you have problems of serial correlation, you have problems of heteroscedasticity, for which you will be able to use ARIMA model, GARCH models, everything else. So these are the various aspects that I just wanted to cover. So if there are any questions which are there, please feel free. And if there are any questions which are there, or otherwise, I would request if our HOD ma'am is there. Ma'am? Okay. So, okay. So any questions? Any questions? So any questions? If you have any questions, please let me know. And anyways, the videos as well as in terms of the materials which are there will be given to you. Okay, so that has been told by the organizers also. So if that is the case, you will be receiving all these materials to go through. And for part of 3 days multi-in research, and hope in these 3 days within these 6 hours I have tried to justify as much as possible with respect to the various tools as well as techniques, and just given you a gist on what softwares or what are the limitations of the softwares are when you are analyzing a lot of data. So instead of going through in terms of Excel as well as in terms of SPSS, nowadays, if your data is very, very huge and if you want to analyze that data in a well-defined manner, it is better to go for these open software, which will be able to help you a lot in data analysis also, which can come in very, very handy in your PhD research or while writing research papers. So thank you all very much. And okay, no problem. The codes, everything else, I'll share it, no problem. So thank you all. Thank you very much. Ramya madam, is there any concluding remarks? Thank you guys. Thank you.